and welcome back. So far, we have seen inventions that could plot a sinusoidal wave, that could add the sinusoidal waves of different amplitudes and different wavelengths. And we have also seen some inventions that plotted spirals, polygonal spirals, and regular spirals that were geometric and arithmetic and so on. Now we are going to combine two of these inventions. One was for plotting the spiral and one for plotting the sinusoidal wave to create a damped sine wave drafter. So here we go. Here is the contraption and it is plotting the sine wave. Notice the amplitude. Okay, notice the height of these bumps of these sinusoidal waves, and you can see it is diminishing. It has become smaller and smaller, and that is the damped sine wave we have got. Let's see how the whole thing works. So we are going to start with a disk like this, which has got a radial slot, a straight radial slot like this. And on top of that, we'll place another disk with a curved slot. Now this curve, we have chosen to be a spiral, okay, a mathematically correct spiral. And you can see these two slots intersect over here, creating a opening. Now through that opening, we will place a pin. So that pin is going right through over here. And if we can make these two disks rotate in the same direction, but not to the same extent, then the two slots will move relative to each other like this. So over here, the radial slot is rotating, the radial disk with a radial slot, and the top disk is also rotating. It is rotating little faster. So this curved slot is kind of overtaking the radial slot, and thereby their point of intersection is shifting towards the center. So this pin is coming radially inward, this green pin that we had put in. And if you are rotating and at the same time coming towards the center, what will happen? You will trace a kind of a spiral. You are spiraling towards the center. And that is the crucial idea of plotting a damped sine wave. So how can we make these two disks rotate at a differential speed? That's easy. We will take a pulley like this, and you can see this pulley has two smaller pulleys all combined together in a single unit, and one is little bigger than the other. And then simply use two belts or two rubber bands like this to connect the bottom disc to this pulley, and from this pulley we will take the motion back to the top disc. Because of these two different radii, the two discs will rotate at a different speed. Then in this pin, we are going to put a link, a crossed link like this with a slot. So when the whole thing rotates now, this slot or this slotted link is going to go back and forth. So this is going to oscillate. But it is not going to oscillate to the same extent every time, because as it oscillates, the pin is also moving towards the center. So the pin is going to dampen those oscillations. The oscillations are going to die down, and therefore it is going to be a damped oscillation. Now, if we can make the whole thing move forward, that will give us the damped sine wave. So let's provide some motion, some mobility. For that, we will start with some wheels over here. Between these two wheels, we are going to put a cone pulley like this over here. Connect it to another cone pulley over here, so via a belt. And over here we'll put a bevel gear and another bevel gear. Bevel gears are nothing but kind of cones, okay, which engage and transfer motion. And the whole thing we can put in a box. Okay, so provide some support or a frame. Just to stabilize this frame, we can have a front wheel, because you need 3 wheels or 3 points to define a plane. So our motion is now ready. Okay, these wheels will rotate on paper. That will rotate this cone. That will drive via this belt, this top cone, then this bevel gear, and the motion has come up to this point. And that is where our bottom disc comes in. Then through the belt, the motion will go to this compound pulley, and then via this belt, it will come to the top belt, and then through this pin, it will be given to the slotted link. And from this slotted link, it will come to a pencil. And now let's see how the whole thing would move. Okay. What's the oscillation of this pencil? It is going to die down. See, it is not going to the left as much, not going to the right as much, and now it will die down to a center. Now let's make it move. There. So that's our damped sine wave drafter. And of course, you can use the previous invention, that is the Fourier drafter, which is capable of adding these sine waves. So now you can plot damped sine waves as well as add damped sine waves of different damping, different amplitudes, and different wavelengths. How to change the damping? Just change this pulley over here. Uh, just have a different ratio of the top and bottom disk radii, and that will change the damping.